Well, good Sunday morning coffee. Over in Portland, it's rainy. Looks like it's going to be rainy for a while. It's really hard to tell how the weather's going to come through the area. But if you look at the satellites photos, you get an idea of the waves of water moving through the atmosphere. I think this is teratons of water in the atmosphere. Somewhere I did the math of how much would an inch of rain on an acre of land weigh. And I forget what the total is, but a gallon's what, about 8 gallon of water is about 8 pounds, something like that. So the word for the day is, I think I'm going to mispronounce it, but pelagic. Pelagic fish, or pelagic species, because they include some non-fish. It has to do with ocean travels. Pelagic fish basically do not have a home state. It's the ocean they live in, like the Pacific, the whole word Pacific. They might travel up and down the coast of one of the Pacifics. So it could be along China, Japan, to the west of us. Or from Alaska down, or a great big circle. It all depends on the kind of fish. But we know they have these cycles they've been doing longer than we have. So, in some extant way, we're all related, right? But, so those fish and their swimming patterns, coupled with their age, their longevity, these fish live to be, human ages, let's say, for example. Depends on the species, but they live many years and they get huge. You're talking about sunfish, sailfish, swordfish, killer whales, all whales. Whales own the oceans, not the land, so they pretty much go where they please or where they know. And they know food, and that's kind of what they follow because that's what we all need. So, those fish are at the top of a food chain that consists of a million other organic mechanisms put together because nutrients got washed out to the seas from the land. Phytoplankton, microorganisms feed on those foods. The foods get into the organisms by what the organism needs. So pretty much everything needs calcium, right? Everything needs carbon, but everything needs about 40 other minerals in order to exist because of the interactions across all the subtle chemical things going on. So because of that, those pelagic fish are the top of that food chain. So that biological accumulation down at the subspecies level, at the basic primal chemical level, these things are passed up and accumulated through living systems. In geological time, these things can migrate through the planet itself, through mechanical and chemical reactions. So that's plate tectonics. But those fish have been swimming for longer than we have. They have lived their entire life in their world and only seen ours through fish eyes. So I don't know what we look like to them. They listen and speak with sonar and frequencies we know about. We can listen to them, but we don't understand yet. So these are immensely intelligent mammals, animals that have passed along their secrets to life to their offspring. So the animals at the top of the food chain, and that's us as omnivores, especially us as omnivores, because most fish species, these pelagic, these long livers, the tuna, that we consume in mass quantities, the size of those tunas are decreasing because we're destroying some of the population. We're actually changing population dynamics and genetics by overfishing for continuous generations of these species. So those fish are at the very top of the food chain. Whatever the plankton consumed, remember we said cesium is a calcium mimicker? So if 1 in a million cesiums got accumulated into the phytoplankton, and the krill eat the phytoplankton and consume millions of phytoplanktons, all of a sudden the krills have 15 cesiums per krill. Now, whale eats the krill by the tons. By the tons. That whale has just, and I'm only using cesium, there's biological uptake paths for almost all elements. Your body will either ignore them and pass them through, depending upon what and how, right? Or your body will nest and store it, or use it to build bones and muscles, or keep your thyroid healthy with all the chemicals it needs, like iodine. So all of these things are really subtle little elements in radiation that actually add to our genetic changes over time. They still are a part of the genetic change that all life has gone through. And it's a very hard conversation to find about the effects of radiation through the plant's biological history. And I'm just curious about it because we know it happens. We know over the period the Earth has existed through decay properties that there was a much higher energy level, a high energy particle level in the atmosphere, or not. So that's something I've just, it's decades on the mind. What's going on there? When will somebody speak to this like I want it to be spoken to? So it's just a matter of incomplete science, incomplete studies, people building bombs instead of studying how to build a future. It's pretty easy to blow stuff up. We've learned that a long time ago. So these pelagic fish, pelagic species, ocean species, with huge ocean territories, feeding, every day of the year, accumulating these elements into their bodies. So, if you're my age, when I was a kid, was when the tuna revelation came out. That there was mercury and lead in tuna fish, especially in swordfish. Remember the age of these fish, what they're eating, how long they've been eating it. They just keep on adding into the internal resources. So again, bones needing calcium might be more structured, might have a few more nuclear isotopes waiting decay in the bones over time that could change something. Again, there's, I've gotten hours of videos about the math behind this and why it's true. It's true because when you walk in the casino, you're going to lose. That's the odds in the casino door. But the odds at the table, you feel better about. So, those fish out there, this accumulation happens. It is simply a fact. It is biological accumulation, biological half-life, biological uptake. It is elemental and particles and dust and soot, because the absorption pathways for these are through the skin. Okay, if something falls on your skin, it can be absorbed through it. That is a true path of poisoning for some specific chemicals. If they're in the air, they can work the same, but it's such minute amounts that should you worry about it? We don't know. We don't know. So, all right, back to those fish. So, understanding that from back in the days when Jacques Cousteau was cool, right? Remember those days? Those inspirations on television? It just kind of disappeared. Talking horses lasted, though. So, the understanding something about biological uptake, pollution hazards, chemical hazards, I decided to go Hanford studies, because Hanford is the longest, most detailed, most known study of biological interaction with U.S. populations that we have. Why it's not that studied elsewhere is probably one of my other videos, or a few of them. So this is how pollution in general works. I speak to nuclear because it is kind of a pinnacle pollution. Although dioxins have such a long environmental life, they will break down. The sun and some of the energies from sunlight can break them down. There might be organisms that can break them down into something less harmful, because those are chemicals. Those are long chains of elements tied together, and somebody looks at those. So, 13 minutes. I hope this is listenable. So, going to Hanford and studies at Hanford, I had seen it pops up in the papers. They're very old now, but one of the alarms at the Hanford site of employees coming into the plant. So this is the 1950s or 60s. There's instruments sensitive enough at the gates to these plants that a few people got alarmed for plutonium. And after studying, it was learned that those few engineers or mechanics or workers or somebody that was in that plant that went through that level of testing had been out to the Washington coast and had oysters. The oysters had plutonium in the oysters. It was enough plutonium that they ate it. It was absorbed into their bodies somewhere and triggered alarms. So that was, I forget, it was, I think, based on 3 or 4 people, maybe more. So that was just real life. That was reported. The reason plutonium was such a huge problem is the Hanford site's first reactors were open-run reactors. Anything that came off of the materials being made into plutonium, including plutonium, were flushed down the river. That is exactly where they went. It was single pass cooling. And in the case of a catastrophe, in the case of a worker washing their hands into a sink, it went out to that river. So that is the reason they came up with the double pass systems, which later became GE boiling water reactors. Or Brown and Root was a different technology stream. So there were only a handful of companies. Basically, DuPont was the chemical company behind a large part of this. Dow was the other chemical company. So they had split the castles in half, and then you had engineering companies like Bechtel, Brown and Root, and others that have been bought up and absorbed into other conglomerates. That is all those companies do. They're engineering powerhouses that can design a bridge to last generations, design a pipeline to maybe be more resilient, design a pipeline that's a better idea than trucking stuff on the highway. So there's trade-offs, balances that are made in decisions that maybe folks need a little more awareness of. And right now they're for profit secrets. They're not for the good of our nation's secrets. So those pelagic fish that are eating for 30 or 40 years food that has been contaminated with radiation that has half-lives in the millions and billions of years, or in the 50s or 10s or hundreds of years, because all of these matters. Iodine is short-lived, but for some period of time you can accumulate mass amounts in your body. If you get lucky, it'll be used and swept away and replaced by good iodine. If you're unlucky, if there's enough there, then you're unlucky. So those poor unlucky fish turned into, again, this was 1960s, that the tuna and these pelagic fish were identified as having those heavy metals in them that are a danger. So what does that mean? In the research of those heavy metals are isotope studies. They had these technologies those decades ago, and there's two types of isotopes for lead. There's a lead isotope that's normal to this earth, which would mostly come from coal and oil, and man's extraction technologies releases up into the environment and put into our earth cycles. So those heavy metals mostly came from when Europe began burning coal, when China began burning coal. Europe learned about coal and got off of it. They ran out of trees to burn, so new energy sources came up, and you can name them, you can think of them, because these are new to us. Oil is new to us. It's it's not a human invention. What we do with it is a human invention. So these large, huge cycles you can extend over the life of the planet, right? The seasons come and go, El Niños come and go, solar cycles come and go, civilizations come and go. So those fish swimming out there have leads and mercuries in them. The only way to identify them is through examining dead bodies, the result of those poisonings, right? Or you have people go out and look for it to study it. So pelagic fish, biological uptake, body half-lives. The calcium you run through your body is also excreted. You have bone loss with aging. You lose calcium. That's the bulk of the bone loss that you're losing, is calcium, or the constituents that are holding the calcium molecules together, because these are molecules. That's a word I forgot back there. So, yeah. So from Hanford, proven studies, we learned that if you eat contaminated shellfish, it can accumulate in your body for long periods of time and raise the risk of something happening. Hanford study. Go back and look. That Hanford study I found by reading National Academy's press documents, going through the references and finding those papers, and then digging back. A lot of that was funded through Battelle Labs, or the Battelle Institute. So that's some of the primary federal contracts you see this information through. And then they went to universities with grants and information, and those are the folks that helped to put a nuclear reactor into our Portland University here. So this is part of the chess game of nuclear, and people keep on making us play pickup sticks with social issues. For some reason, I think that's on purpose. So those fish are at risk. People in labs do look for these constituents and a lot more. I've only mentioned a couple of isotopes. There's a lot more they can look for. And it actually is these, I call them plume maps. That's too simple. But those are maps that show how things can spread over distances and time. And some of them are predictors and not very good. Some of them are historical and not very good, but others are. And even the not very good ones you can put together if you read and see enough of them to say, you know, there's a story here that Rachel Maddow might better tell. So this the effect of this accumulation over generations, over decades, Chernobyl has shown that genetic damage is passed through generations. You can go find the story of where Chernobyl children have been sent to, what other countries are trying to take care of them, and they're still struggling, they're still in pain. There was stories out of Chernobyl of tonsillectomies normally being done without anesthesia because they didn't have anesthesia for a tonsillectomy. Can you imagine that? I hope you can, because if your child needed a tonsillectomy, I'm afraid you would help hold them down. I'm not afraid, I'd be proud of you, because you'd be saving the child's life most likely. So these are the things you're going to run across in an emergency, you know. I don't know how you plan for that. How do you plan for coming out of a hole in 6 months? Needing food, water, energy, solace, companions, something to look forward to, and you've hid yourself for what kind of future? So back to those pelagic fish. So in some of that research, all right, we're looking for mercury and lead. Well, that's not nuclear. Well, its isotopes are nuclear decay properties. There is a ratio of not normal lead, because it's man's pollution lead from coal-fired plants that were grandfathered to be allowed to pollute for decades and didn't clean up their mess and played games with laws to avoid cleaning up their mess, and they called that profit. So it's an odd world that has been built up around us. But that is part of the nuclear story. So we know that these things have effects, period. It's not a question of it. It's not if, it's a question of how much. And we can understand this. We can mitigate, plan, and put money to the right things to do something about it. And among that mix is climate change. But closing 100 U.S. nuclear facilities in the next 20 years is going to be How many trillions of dollars? Someone else can do some math. Help me out here. So I'm at 25 minutes. I'm going to stop, and I'm going to leave this to questions. And if you've got this far, bless you, my friends. Have a great Sunday. Enjoy your coffee, and peace out.